Hey everybody, it's the Science Geek, Mr. Geis. Today's objectives are differentiate between an observation and an inference. We're also going to identify the steps of the scientific method, as well as identify the parts of a controlled experiment. Before we get into our scientific method lesson, I want to take a look at observations and inferences. I'm going to provide you with definitions and examples of each of them based on the two pictures below showing grass A and grass B. First, an observation is the act of noticing and describing events or processes in an organized way. Some examples of observations based on these pictures are grass A is green, grass B is brown. If we want to get a little bit more intellectual, we can say both grass A and grass B are the same type of grass. Inferences are a logical interpretation based on what scientists already know. Some examples of an inference in this case are grass B may not be getting enough sunlight or water or nutrients to stay living. Grass A could be receiving fertilizer. These are both valid inferences because we've been growing grass for a long time. We know a lot about the different types of grass. We know a lot about the conditions in which grass grows the best. So we can infer things that we already know into making an inference. Now we're going to talk a little bit about the scientific method, which is an organized way of solving a problem. This is really nothing different than trial and error. There are several steps that make up the scientific method. The first step is to ask a question, followed by state a hypothesis, conduct a controlled experiment, collect data, analyze data, and make a conclusion. Alright, so step one, ask a question. Based on our observations and inferences that we already made about grass A and grass B, it's time to ask a question. One of the biggest questions that comes to mind when looking at these two pictures for me is, why is grass A healthier than grass B? Step two is to make a hypothesis. A hypothesis is using observations and inferences to make an educated guess why something is happening. The hypothesis should be an answer to your question. Our question was, why is grass A healthier than grass B? So let's take a look at a couple possible hypotheses, which are answers to our question. Grass A is healthier than grass B because grass A has been watered regularly. Grass A is healthier than grass B because grass A has been receiving sunlight each day. Grass A is healthier than grass B because grass A has been treated with fertilizer. These are all valid hypotheses, but we're going to just pick one to kind of move on with the scientific method with, and that one's going to be our third one. Grass A is healthier than grass B because grass A has been treated with fertilizer. Step three is to design a controlled experiment. A controlled experiment is an experiment where only one variable changes. In this example, our one variable that changes is the fertilizer. One plant is receiving fertilizer, the other one is not. Next up is the controlled variable. A controlled variable are all parts of the experiment that are the same, that do not change throughout the experiment. In this experiment, we have several. The types of grass being used, sunlight, water, soil, are all controlled variables. Next is our manipulated variable, the variable that is being deliberately changed. In this case, the variable that's being deliberately changed is the fertilizer. The responding variable is what is being measured because the fertilizer is being added, or because the manipulated variable is being added. Okay, this is our data for our experiment, and our data is growth. We're adding fertilizer, and what's going to respond to the fertilizer? The amount of growth in the plant. Last is the control. The control is the experiment ran under normal conditions. How would we grow grass normally? Well, we would just use regular soil without fertilizer. We'd give it water, we'd give it sunlight, and we would have the regular soil, nothing else. Step 4 is to collect the data. There's two different types of data: qualitative, which is based on characteristics that we know. So we know how big a golf ball is, so we could say golf ball size, and everyone's pretty much going to understand the general size of that. All right, we could say violent reaction versus a weak reaction. We could also say red because it's a color that everyone knows. Quantitative is more specific and it's based on numbers: 1 milliliter, 2 centimeters, 84 seconds. In this experiment, we would collect both types of data. We would take pictures of the grass so we could show color, healthiness, etc., which would be qualitative data, and we could measure the growth in centimeters, which would be quantitative data. Our next thing that we would do after collecting this would be to organize the data in the form of a table, graph, or chart. I will make a tutorial on graphing, and I also will hand out a packet on graphing so you could refer to it throughout the year. Step 5 is analyzing the data. After I ran the experiment, I collected data and then I organized it into this chart that is easy to read. On the left side I have the number of days, and there was 20 in this experiment, and I combined day 1 through 14 because there weren't any growth throughout those days, so the plants did not germinate, they did not grow. And starting day 15, I measured each plant in centimeters. Analyzing the data really just means that you're going to offer some trends or general statements that provide an overview of the outcome. Based on this data, we can list a couple trends. A couple examples are: the control grew first but also grew the least. Grass A, the Miracle-Gro fertilizer grass, grew larger than grass B, the control. Part 6 is the conclusion. Your conclusion should include the following: a bold sentence stating whether you proved or disproved your hypothesis. For example, in this experiment, the hypothesis grass A is healthier than grass B because grass A has been treated with fertilizer was proven to be correct. The data shows that the plant that was given fertilizer grew more than the control. If the hypothesis is ever disproved or proved false, you should change the hypothesis and retest. Another part of the conclusion that you must have is to explain any experimental errors. On day 5, grass A was accidentally not watered. This could be the reason why grass A took a little longer to germinate. The next step is to list any improvements or changes to the lab. This lab could be improved if the grass was tested in a more controlled environment. The last part of this lesson, and something that I get a lot of questions on, is what is the difference between a hypothesis and a theory? As we stated earlier, a hypothesis is an educated guess based on observations and inferences. A theory, on the other hand, is a hypothesis that is well supported and never proven false. A great thing about science is nothing is ever concrete. If we ever would prove a theory false, it would be disregarded as a theory as long as there was not any experimental error. It has to be able to be proven false over and over again. Now, on the other hand, a hypothesis that is proven to be correct over and over and over again can be changed into a theory. So just a couple things to keep in mind as you go through the scientific method on your own. I hope we were able to accomplish today's objectives. If you have any trouble differentiating between an observation and an inference, or identifying the steps of the scientific method, or identifying the parts of a controlled experiment, please bring any questions that you may have to class. Please also remember to go to Sophia and take the quiz on this lesson. I will see you next class.